So for bundle branch blocks, you don't have to know much. All you have to know is that you have to look at the QRS complex, right? You're given an ECG for a bundle branch block. What you're going to look for is for the QRS complex. What is the issue with the QRS complex? It is wide, right? So it's going to be bigger than 3 small boxes. Okay, 3 small. I'm just going to put small. Okay, bigger than 3 small boxes. So let's take a look at this example right here. So here the ECG is kind of messed up. There aren't very obvious QRS intervals, but let's look at V1. For bundle branch blocks in general, the lead that you're always going to focus is on V1. So in this lead, what do we see? The Q starts here and the R is right here and there's no S, so it ends right here. So this is the distance right here. This is the distance. As you can see, this is definitely longer than 3 small boxes. This is almost the size of 2 small boxes. So this is clearly a bundle branch block. Whenever you see a QRS that is wide, instantly bundle branch block. Now we want to determine, is it right or is it left? Okay, that's quite easy as well. For a left bundle branch block, you have a negative deflection of the R wave, right? So this is the R wave. It's negatively deflecting, so this means that it is left. So this is the left bundle branch block. And here we look at the same thing. We're looking at the lead in V1, and here it doesn't show the small boxes, but we can see clearly that it is greater than 3 small boxes, because this is almost the size of a whole box, right? And so this is a positive deflection. So what does that mean? Instantly right. This is a right bundle branch block. Now I can actually explain to you why that is, just so that you can memorize this and understand it at the same time. Here we're going to have our right ventricle. Here we're going to have our left ventricle. Now if you know where the V1 lead is placed, it's gonna be a lot easier to understand this. The V1 lead is usually placed on the right side, so let's just represent the V1 lead right here. This is the V1 lead. And so when we have, let's say we have a left bundle branch block, so this is the one that is blocked. This is how the depolarization is going to travel. It's going to travel through the right bundle branch block, it's going to travel through the right bundle branch, and it's going to make its way all around, and then it's going to come back down and make its way to the left ventricle. So this is why it's wider, because it's going to have to take a longer path in and back out. And as you can see, it's moving away from the V1 lead. It's moving in this direction, and so therefore a left bundle branch block makes a negative deflection that looks like this. Whereas if the right bundle branch was blocked, the opposite would happen, right? So the depolarization would travel through the left ventricle and then come back and go this way, and it's traveling towards the V1 lead, and so we're going to have a positive deflection that looks something like this.